Hi there and welcome again to Cambridge Advanced Level Mathematics. Here's the channel where we prepare students for the advanced level mathematics examinations. Of course, we do this by helping them to practice past examination questions from previous years. And in today's lessons, I brought you a pure mathematics question from paper 1 of 2022. And the question reads as follows. In the expansion of 2x squared plus k squared divided by x to the power 5, the coefficient of x to the power 4 is n. In the expansion of 2kx minus 1 to the power 4, the coefficient of x squared is b. The first question says, find a and b in terms of k. Second question, given that a plus b is equal to 216, find the possible values of k. Of course, this is a purely binomial theorem type of question, and so before we proceed any further, we need to make sure we understand and know how to handle our binomial theorem. Now, if we have a binomial such as a plus b, plus x, a plus x, I beg your pardon, a plus x to the power n, the general term in the expansion of this binomial is given by n r a to the power n minus r x to the power r. This is the term in x to the power r. Now, first of all, notice that the sum of the terms of both x and a, when we add them together, they sum to n. So n minus r plus r is equal to n. Secondly, what does n over r mean? It's not n divided by r. It is notation which stands for nr is equal to n factorial. It is defined as n factorial divided by n minus r factorial r factorial. What does that mean in practice? For example, if n is equal to 4 and r is equal to 3, then nr will be 4, 3. Remember, this is not a fraction, it's notation. This would mean 4 factorial divided by 4 minus 3 factorial and 3 factorial down here, which of course is 4 times 3 times 2 times 1. That's our 4 factorial divided by 4 minus 3 is 1. 1 factorial is just 1. So we have 1 factorial here, and of course there our 3 times 2 times 1, which is our 3 factorial. This of course cancels with that, and we are left with 4 divided by 1, which is equal to 4. So 4, 3 is equal to 4. Okay, that's the notation there. Right. Now, how do we use this to handle our problem there? Okay, so now we want to expand 2x squared plus k squared over x raised to the power 5. So our n is equal to 5. Our a here, our a would be 2x squared. So a would be let's just say a is equal to 2x squared. And the x term there will be taken over by k squared over x, right? So our general term of the series will be n r. A, which is 2x squared to the power n minus r multiplied by kx squared over x to the power r. Okay, all we did here was replace our a with this and replaced the x with that. Now, the problem is we want the term in x to the power 4. Now, when we look, of course, let's simplify things. We want the term in x to the power 4. So this means that it will be nr. We don't know what r is going to be. So let's simplify this. This will be, when I open the brackets, I will get 2 to the power n minus r multiplied by x to the power 2 bracket n minus r. Also multiplied by k to the power 2r x to the power r. Let's just check what we have done to see if it makes any sense. Here is our general term. And in terms of this expansion, it will be looking like this. So, of course, this is our a, this is our x. I open up the brackets. This is what I get. 2 is raised to the power n minus r, and x is raised to the power 2n, 2 brackets n minus r. That's the x on top. The x down here is raised to the power r. But we want the term in x to the power 4. And we know that when we are dealing with indices, when we divide, we subtract the powers. So the powers of x on top, when we subtract them from the powers of x at the bottom, they should add up to 4. We should end up with an x to the power 4. So we can have a little equation here. So we know that the top powers of x there will be 2 brackets n minus r minus the power down here, r, should equal to what? To 4. So we want our r to be such that when we subtract what is on top here, when we subtract what is down here from what is on top here, we end up with a 4. Of course, we can simplify this. This is 2n minus 2r minus r is equal to 4. We know that our n is equal to 5. So 2 times 5 will be 10. So we have 10 minus 3r. Of course, you can see the 2r minus r there is equal to 4. Let's subtract 10 from both sides. We get minus 3r is equal to minus 6, meaning that r is equal to 2. So the term in x to the power 4 is given by r is equal to 2. Let's just go through slowly what we have done. Here is our general term. We have an x on top here raised to this power. And there is another x down here raised to that power. At the end of the day, this power and that power must subtract to 5 because we are dividing. So we end up with this equation. When we simplify, we get our r is equal to 2. So therefore, let's see what will be the result there. I'm looking for my rubber. Okay, so we have found that r is equal to 2. Our r is equal to 2. So, but what about, now that we know our n, it is 5, and our r, we have calculated it to be 2. So our term, the one that we are very interested in, will be 5 for n2 there, multiplied by 2x squared raised to the power 5 minus 2, which is 3, because r is 2, n is 5, multiplied by k raised to the power 2 times 2, which is 4, x raised to the power x to the power 2, which of course should simplify to, let's first of all deal with the x's and the k's there, which is 5, 2 multiplied by, well, 2 to the power 3 is 8. So this will be 8. X raised to the power 2 times 3, which is x to the power 6. and k raised to the power 4 there, k raised to the power 4, divided, of course, here by x squared, which is 5, 2, 8x to the power 4, because it's now 6 minus 2, which is 4k to the power 4. Now we need to deal with our 5, 2 there, the coefficient. So 5, 2, 5, 2 would be, we know that 5, 2 is 5 factorial divided by 5 minus 2, which is 3 factorial divided again by 2 factorial. Remember, it's n factorial, n minus r. R is 2, so 5 minus 2 is 3, and then of course our 2 there. So that gives us 5 times 4 times 3 times 2 divided by 3 times 2 times 1 times 2 times 1. Times 1 there. So this cancels and that cancels. We are left again with 20 divided by 2, which is 10. Right. So here we have 10. This now is 10. So multiplying the 8 there, we end up with 8x to the power 4, k to the power 4. But what are we told? We are told that the coefficient is a. So this is equal to a. So we can write there in our box. Let us write it in red. We have found that the coefficient of x to the power 4, which is k4, 8k to the power 4. So we can write here 8k to the power 4 is equal to a. Okay. All right. So we are done with the first one there. Let's handle the second one. We want to expand this. We want to expand our 2kx minus 1 to the power 4. Right? Again, our a will be this, and our x will be minus 1. So in our general expression there, we will have nr multiplied by 2kx to the power n minus r multiplied by minus 1 to the power r. Okay? Now, they are saying the coefficient of x squared will be equal to b. The coefficient of x squared will be equal to b. So what is r there? Our n is 4. So we need to have n minus r is equal to 2. In other words, because this is where our x is, it will appear in this term. So n minus r should be equal to 2, which means that our n is 4 and r, we don't know, is equal to 2, which means r should be equal to 2, because 4 minus 2 is equal to 2. So we need the term in r is equal to 2. And that term is, so we now have there, our n is 4, so we have 4, 2. Multiplying 2kx, and we found that r is 2, n is 4, this will be 2. Minus 1 to the power r is 2. So minus 1 to the power 2 is just 1. So our term will be 4, 2. 2 squared will be 4. And k squared there. And of course, our x squared. But what is 4, 2? 4, 2 is 4 factorial, which is 4 times 3 times 2 times 1, and divided by 4 minus 2, which is 2 factorial, again with another 2 factorial. So this 2 goes, that 2 goes, so we're left with 12 times 3 divided by 2. 12 divided by 2 is 6. So this will be 6, is that right? 12, yeah, 6 multiplied by 4 k squared x squared, which of course is equal to 24 k squared x squared. What are we told? We are told that this coefficient here, coefficient of x squared, this part here is equal to b. So straight away there we can say 24 k squared is equal to b. Right. So we've answered the question, because the question was saying find a and b in terms of k. A is equal to that, b is equal to that. Well, it goes on to say, given that a plus b is equal to 216, find the possible values of k. Okay, now let's put together this equation and see what we can arrive at. It should be a pretty simple and straightforward exercise there. So I don't think I need that. Okay, right, so we can do that. So what we have here is, we are told a plus b is equal to 216. So 80 k to the power 4 plus 24 k squared is equal to 216. That's what we are told. Okay, let me see. Does 8 go in there? Here it goes twice, remainder 5 into 50. Yes, so here by 8 it's 10 there. By 8 it's 3. By 8 it's 2. Remainder 5 into 56, it's 7. So we have 27 there. So bringing everything to one side, we have 10k to the power 4 plus 3k squared minus 27 is equal to 0. So what can we do? Let's change it into a quadratic equation. Let k to the power 2 equal to t, which means k to the power 4 is t squared. So we have 10t squared plus 3t minus 27 is equal to 0. Is it possible to factorize this? Let's go straight to the quadratic formula. So t is equal to minus 3 plus or minus the root of 9 minus 4 brackets, a is 10 multiplied by minus 27. All this, of course, over 2a, which is 20. Let's simplify this. This is minus 3 plus or minus, I need a calculator here. This, of course, is going to be a plus because there's a 2 minuses there. So it's 40 times 27, which is that 1080, plus our 9 there, which is 1089. So this will be 1089 inside the square root sign divided by our 20 there. And we have a square root for that. Square root, which is that it's 33. Square root of this is 33. So we get minus 3 plus or minus our 33 divided by 20. So there are two possible answers there. So it's either we have a minus 33 minus 3 minus 33, which gives us a minus 36 over 20. or a minus 33 plus a minus 3 plus 33 over 20. So, or 30 over 20. Okay, so those are the possible values of t. But our t is equal to k squared. Our t is equal to k squared, which means that if our t is equal to this, which is 3 over 2, or that would be what? Minus 9 over 5. 9 over 5. So our k is equal to the square root of this or square root of that. This, of course, is completely out because this will be an imaginary number. So the only possible value for k is 3 over 2. I just want to make sure there that we are on the right track, because we said t is equal to k squared. So then k squared would be either this or that, in which case k is the root of. So k would be equal to the root of 3 over 2, and it can't be the root of minus 9 over 5, because then it becomes an imaginary number. So the only possible value is plus or minus the square root of 3 over 2. That was the answer there for our question on the binomial theorem. Till I see you next time, bye-bye.